using the screen here. Yes. All right. So I work at a company called Open Value, and the company is fully specialized in bespoke software development in the Java ecosystem. And we do that in different countries, in the Netherlands and Germany and Austria and Switzerland, with multiple offices where we have small autonomous teams that are all highly specialized in building custom software. And we like to keep ourselves on top of the latest developments by continuously sharing our knowledge with the outside world. Because by sharing knowledge, you challenge yourself to keep up with everything that's happening around you. We do this through conferences, meetups, trainings, and also through talks like this. So my name is Roy Wasse. I'm co-founder of Value, together with Bert Schrijver, who will be the next speaker. And I've been active in software development communities basically my entire career. I helped co-organize several conferences like JFOL in the Netherlands, JSpring, also CodeMotion Amsterdam, where I was a program lead for a number of years. And I really like to be involved in this field because, you know, it's a constant challenge to, study what's out there. There are continuously coming new tools, languages, frameworks, approaches that enable you to build software in a better way. But how can you pick the best possible things and organize your own team in the best way? And how can you do that in a cost-effective way? How can you build software that is adaptable, maintainable, and scalable? These are really relevant questions. So first of all, you need a software language to build. First of all, you need a programming language to build, of course, piece of software. And what language should you pick? Well, you can ask all kinds of experts and you'll get some opinions. Well, if you ask somebody from Open Value, you'll probably get an answer like Java, because we're specialized in that. But you can also have more, maybe a better researched view. And you can study GitHub is, of course, the place where open source projects are stored. And you can study these repos and try to find out which languages have the most activity. You can go to Stack Overflow, the place where developers ask each other questions about technical problems and see what.
Your microphone, Bert-Jan. No, still off. We don't hear you.
You're on mute.
So I hope you got most of my previous slides, but let me repeat about this slide. So Redmonk is an analyst firm from the UK that every year publishes a report that studies both Stack Overflow and GitHub and try to find out what are the languages that are most used over there. And it's interesting to see that JavaScript is up, and the second place is Python and Java, and PHP is in the fourth place. Maybe a little bit of surprise, because maybe in the enterprise software development world we see more Java and C#. But I think that in the SMB business and maybe also a little bit more in hobbies and in study environments, PHP is being used quite a lot. We see CSS on the fifth spot. And this is, you can argue if this is really a language. You cannot build any program with CSS. It's mainly for styling, of course. It's not Turing complete, but it is nonetheless used a lot. And if you look at the last couple of years, Redmonk also published a chart that shows how this ranking has evolved the last 8 or 9 years. Then you can see that the top 3 is basically the same over all these years: Python, Java, and JavaScript. But you also see some newcomers. So at Open Value, we mainly build software in the Java space, and more than half of our projects are actually being built with Kotlin, maybe a technology that you heard about as well. Well, it is gaining some ground, but it is only in the 18th spot. Also interesting to see here that Go language is also not that high. We see that a lot as well. And I think that in the enterprise world, just like I said about PHP, maybe you see a different selection of languages more than you see outside the enterprise software development world. If you look at job advertisements, Then you see again Python, Java, and JavaScript. But you can also see here that Java is actually the most popular language in Europe, and Python is very, very popular in US job posts. So this is also a way to look at it, and you basically just see the same kind of languages, and Ruby is a bit more down compared to the other rankings. All right, so now that you know all this, how can you pick the best programming language for your next project? Well, I would say definitely look at what's really popular in the area where you live. Are there developers that are proficient in the language that you want to use? And do you also expect that this language is going to be popular in a few years? So you might want to go for an open source alternative, because open source projects tend to live a lot longer than closed source projects. And also have a look at the development community. Is it really active? And look at the rest of your application landscape. What kind of applications do you already have there? Which languages are they being built with? And is it easy to migrate from that language to the language that you want to use now? All right, so that was about programming languages. Let's now talk about a trend that you probably heard about, and that is low code. There are a lot of advertisements on the radio, for instance, that promote different kind of low-code platforms, and you might know these solutions under other names, like model-driven development, fourth generation, or even like no-code. And the idea has been around for a long time. You have these pre-built components that are already being tested, and it can help you build an application really fast by giving you standard functionality for search, for login, for making a list of items, etc. And the benefit is that you don't need to code everything yourself. That sounds really good, right? It can save you a lot of time. But the thing is, it hasn't really lived up to this expectation in the past. You see Uniface here, which was a Dutch product, which was popularized as a low-code or a fourth generation language in the 90s. And a lot of applications that were built with Uniface, they turned out to be, well, not really adaptable. Once you changed a little bit of standard functionality, it was really hard to maintain those applications. And in the end, you wished you would have built it from the ground up with a regular programming language. So the question is, what will happen now with this new, popularity of these low-code platforms? First of all, there are a couple of myths. And of course, again, this is an opinionated view. I'm a guy that likes custom software development, but I will nonetheless talk about a couple of myths about low-code. And the first one is that you don't need professional developers if you work with a product like Mendix. And I think this is totally wrong. You still need to think really hard about how to handle data in a good way, how you can integrate a low-code application with other applications, how to design the processes. This is just as easy or just as hard compared to building a bespoke piece of software. The other one is that you cannot really build scalable applications using low code. Maybe you can do like these CRUD applications for the back office landscape that replace like an Excel or an Access application. But if you want to do really scalable stuff online, maybe don't use low code. But you know, you can just as easily build a microservice using low code as you can if you build it in a normal way. But this is also maybe not really valid. And the third one is that you save a lot of time using low code because you don't need to build everything yourself. And I think this is the most important myth, because you know, actually typing in the code as a developer is not the thing that takes the most time. What really takes a lot of time is knowing what to type in actually, what the business actually wants. And of course, this idea is continuously evolving. That's why we need to refactor as we do a project. And this is also the case with low code. You continuously will need to adapt your application, and just typing in the code, well, that maybe saves you a couple of hours if you use a component, but you know, a couple of hours is just a fraction of the amount of time you put in any project, right? So maybe don't go to a low code platform because of that. And also think about it. If you choose for a low code platform, you are kind of vendor locked in, and you need to pay normally also some license costs for using that platform. So I would be careful. But nonetheless, there are a couple of really successful platforms out there, also from the Netherlands. Both OutSystems and Mendix originated in the Netherlands. So Gartner put them in the top right quadrant. So they're doing a really good job. The next thing I will give my opinion about is architectural approaches. So you probably heard about monoliths. these are the types of applications that we used to build maybe in the beginning of the century, the end of the 90s. This huge business application that did all kinds of things, that had a huge code base, and that we would deploy all at once to a server. And well, it was, of course, on the one hand, very efficient. On the other hand, if you changed a little piece of functionality on the one side of the application, unexpected things could happen all around. And these applications over time resemble an Italian dish called, of course, spaghetti, and made it really hard, of course, to adapt to the needs of the business, and it cost a lot of money to make a simple change. So we tried to move to another pattern, and service-oriented architectures became really popular in the zeros of the century. And the idea was that you have like a central point, a bus between several applications in your landscape, and that all the communication would go through the bus instead of the applications contacting each other directly, preventing the spaghetti from happening. But what you did get that way was, again, a central point in your application landscape where you were depending on, of course, enterprise service bus. And all these connections to this bus, well, they were actually also resembling spaghetti. So while this was a step ahead, and it's maybe still a really good idea in some scenarios, it was not ideal in all situations. So around 2013, 2014, Netflix popularized the idea of microservices, where we build small independent services that do just one thing. And a number of these microservices, they would together give a business functionality. And they had a standard interface that they allowed other microservices to talk to. So you could easily just switch from one microservice to another without affecting the entire landscape. So this is probably the architectural style that is being used the most currently. Is what we see a lot here at Open Value. And you can use this in conjunction with event-driven approaches using Kafka and also serverless functionalities. So is this the way to go? Well, yeah, maybe, but also something is happening. First, I want to mention that interesting in IT, we always see that every pattern keeps coming back. And when it comes to architecture, we continuously swing between thin clients and fat clients, between centralized architectures like monoliths and distributed architectures like microservices, because each architecture has its trade-offs. If you have a microservice architecture, you do have like the network overhead. All these services talk over HTTP, and that also adds some complexity to your solution. So yeah, how to choose now between microservices and monolith architecture? Well, what you see here on the slide is explains how these architectures look like a little bit more. And this would translate in something like this: login functionality, wishlist cards, that all have their own data storage. And this picture shows how you should set up a microservice in a really good way. And it's really structured, and you can implement a new technology for your card in this application and replace the database without affecting the rest of the system, as you can see. But what happens a lot in microservice architectures that are not being managed in a good way is this. You get a distributed monolith. Each application, each microservice talks to a lot of different microservices and also go to each other's databases. And then we are back with our spaghetti, but now we have distributed spaghetti. So we do have the downside that we have the network overhead, and we also have the spaghetti of the monolith. So maybe the trend that is maybe now kind of happening is that we go back to the monolith. And I also think that's a good idea, because with modern software development techniques, we can manage a monolith way better. It's way more easy to make it in a modular way. Our programming languages help us do that. We have far better CI/CD than we had in the beginning of the century. And we can make sure that each time that we add a piece of software to our monolith, that is has a good quality, and that we can also replace it in an easy way. For automated test code reviews, we apply techniques like domain-driven design, where we make sure that we compartmentalize the monolith in certain context. So maybe it's a good idea if you build your next application or multiple applications to think about building a monolith. Then containers. Well, of course, containers. Everybody's using containers. We have these Dockerized applications that make it possible to easily ship our application from one machine to another without the need for a lot of local configuration. And with the help of Kubernetes, we can also scale these applications really fast. And this has brought us a lot and has also, I think, fueled cloud adoption. Cloud technology saves a lot of cost. And you see here research by Forbes, and it shows that the cost of maintaining your infrastructure and also spending on staff is going down considerably and has shrunk with at least 20% according to this research. And you have all kinds of different cloud scenarios. You can have a private cloud inside your firewall. You can have partly on-premise and partly in the public cloud that we call a hybrid cloud solution. And of course, you can go all the way to the public cloud. And you can work with multiple cloud solutions. And what Forbes found out is that 91% of enterprise organizations are currently using public cloud solutions, which is quite a lot. But in the research, it mentioned that if they only use a little bit of public cloud, they're already included in this 91%. So maybe it gives kind of a wrong idea, but it is nonetheless, I would say, a high percentage. So if you are thinking about cloud or already on the cloud, what are things you should take into account? I would say that it is, what I see a lot is that companies pick a certain cloud provider. They go to GCP, Google, or they go to AWS, and they do everything on that cloud provider. But what I've seen at different customers, it makes a lot of sense to investigate what type of application you want to land on the cloud, and also compare that to the cost that you would have if you go to one of the other providers. Sometimes you can save a lot of cost because compute can be really expensive at a certain service of Amazon, and it's way cheaper at GCP. So just by comparing these services, you can save a lot of money. So a multi-cloud scenario is probably a really good idea, also to prevent more like the vendor lock-in thing. So let's now talk a little bit about project approaches. I've aggregated some research from the Standish group. Standish investigates many thousands of projects each year and tries to find out if these projects are successful, challenged, or they have failed. And they've done so since 1994. And from all the reports that they published, I gathered the data and put it in the graph that you see here. And the red line represents failed projects, the green line successful, and the yellow line challenged projects. And what you can see is in 1994, less than 20% of the projects were successful. Around 50% of the projects were challenged, and around 30% of the projects failed. Now in 2020, well, we're doing somewhat better, but we're still not doing a really good job, right? It's actually quite bad. Imagine if we were building houses and 20% of the houses, well, they failed, and half of the houses were seriously challenged. So as an industry, we have still a lot to improve, I would say. So what's interesting about Standish is that they also looked at what type of projects are successful and what actually works in projects. So first of all, apparently some people are still doing waterfall projects in 2020. I was quite surprised to learn about that. And you can see that it's, of course, quite a bad idea. It's really hard to think upfront about what you actually want exactly your software to do. We know that we normally don't have really a idea about it, and that the thing that we want to build is constantly changing, of course, and we need to able to adapt. So better work in an agile way. 42% is successful, waterfall 13%. And the other really important thing here is that the size of your project matters a lot. If you have a large software development project, there's a huge chance that you will fail. If you have a small project, there's a huge chance that you will be successful. So better keep your project small. And I don't think that is really happening normally in the places where I come. Because there's, yes.
One question from Oliver. Can you tell something about how the Spanish group defines success?
So I'm not 100% sure exactly about the definition. And I think they look, I read that they look at the goals that the project have and the budget that they have. And then they try to see if you stay within those boundaries. And if you stay within a certain margin of those boundaries, then they say the project is successful. Okay. It's really nice to read these reports, by the way. You can download a couple of the older reports of them online from their website. So another way to make sure that your project is more successful is by thinking about how you set up your team, and especially the maturity of your team. And also you got to make sure that you have a good sponsor in the organization, that you have enough mandate, and that the conditions in where the software is being built, that they are, well, really good. So these are, of course, really logical things, but it is interesting to see that it makes a lot of difference in terms of success rate of your project. So, like I said, small projects, they tend to be far more successful than these large projects. And ideally, you just have one team, I would argue. A small team, maybe 2 or 3 developers that build the core of your product. And maybe it's better to give that team a lot of time to build a larger system than scaling up. But sometimes this is not possible. Sometimes we need to meet, well, certain deadlines because there's some law coming into effect, or we need to adapt multiple applications and they need to work together, and we need other teams that support us in our projects, and we want to scale. And there are a lot of different ways to do that. And I want to talk a little bit about trends that are going on there. I want to talk about feature teams, component teams, and also how you can bring teams together in an effective way. What we mostly see is that a lot of organizations that have existed for a long time, that the first thing they try to investigate is, can we also adapt safe? You maybe recognized this diagram. And I think this diagram already says a lot about safe. It's quite complex with a lot of different roles and processes, and well, it does take some time to really understand why we need all this if you want to work with multiple software teams building on the same environment. You can see that SAFe is the most popular scaling methodology out there, based on research done by Gartner a few years ago. But there are a couple of others as well, and one of them I'm more enthusiastic about, and that is Nexus. Nexus is being promoted by Scrum.org, and why I like Nexus? Well, it's really simple. The hard thing, if you want to build software with multiple teams, is that you have dependencies between teams, and that one team needs something of another team, and they need to wait for each other before they can continue. And this is, I would say, the thing that you want to give a lot of attention to in your scaling methodology. And this is exactly what Nexus gives us. They create like this shared backlog, and there's an integration team that makes sure that things in the shared backlog, that includes all the items that need to be done to be successful with all the teams together to achieve the business goals, that these things are being fed to the teams in a way that minimizes the dependencies, and that the stories that go to the teams, that they are prepared also in a way that they can be finished in the next sprint. And of course, you will still have the dependencies left that need to be solved during the sprint, but therefore they have, again, a really simple solution, a Nexus daily scrum, where one or more of the team members talk to team members of the other teams to see which dependencies between the teams they need to resolve, and they try to do that as quickly as possible, and they have their joint reviews. Really straightforward. I can explain this like I just did in 40 seconds. If you look back at the previous slide, well, probably need a couple of hours to explain it really well. So I would say try to keep it simple. But maybe you can also make another point. We're still talking here about Scrum and how to do Agile in a good way. And maybe it's also time to leave all this talk and all these ideas behind us. And well, maybe we can also say that we're currently more in a post-Agile era. Scrum doesn't make a lot of sense if you do Devops. If you have a sprint where you make a commitment that you will deliver software at the end of the sprint, well, you cannot also have responsibility for maintaining the software that you have built previously and fixing bugs and monitoring the software. Then you cannot keep up your commitment that you also deliver, because you don't know what's going to happen to the software that you've already built. So Devops and Scrum, I would say, really difficult. And also the idea of most of these Agile methodologies is that we well, deliver software at the end of a certain cycle. But if you do proper CI/CD, well, your software should also always be in a releasable state. You can go to production all the time after each commit that you do. You don't need like all these processes from your agile methodology to guide you in doing this. Yeah, you can set it in your pipeline, all the quality checks, security checks that are necessary. But that's something I would say doesn't take away the need for working through following a methodology. And then we have the Spotify kind of approach, where we say we put business and IT together in the same domain, and we let them think about building software together instead of making this division between people who think about what should happen to the software and people who build it. We try to align them in other ways by using these component and feature teams and platform teams, where we think about together how to build it in the right way. So if you have a component team, then you basically say, let's build some generic components that can be used by different teams that have kind of the same need. If you have feature teams, you say, well, we have a team that builds something from A to Z, and all the expertise needed is in that team. And what you now see is that feature teams, they're becoming more dominant in organizations that we encounter instead of the component teams. And we have the platform teams that usually build the generic stuff that is needed to land the application on, maybe some standard frameworks and libraries that the feature teams can use. And this is a really nice setup. And the people in those teams, well, they have roles like this. I think most of them are quite familiar. You also see here the site reliability engineer. That's, I would say, a fairly new role that originated from Google. And if you don't know what a site reliability engineer is, well, it's somebody that makes sure that the software runs in the best possible way. So a site reliability engineer of a team of SREs, they are maybe kind of like a platform team. They have a contract with the organization that they need to make sure that applications meet a certain uptime. And they try to continuously improve the monitoring, the way that software is being deployed, and make sure that the software keeps running better and better. Then I want to talk about some team practices. What we see more and more is that teams, developers don't really like to write a lot of documentation. And what works really well is that this documentation is generated automatically from the software. This can be done in multiple ways, maybe by adding comments in the code that automatically generate documentation about the behavior of the code, maybe by adding certain hashtags to the commits that are being done by the team. It can also go through automated tests like BDD. This works really well in creating documentation on the fly that's always up to date. Really nice and interesting trend. Then mob programming. Maybe you heard about pair programming, where you work with two persons together on the same piece of code. One of the developers is typing in the code, and the other one is aiding and navigating and helping the other person think about the best way to write code. And this is a fairly popular concept, but you can also do this with the entire team, and then we call it mob programming. So you are with 5 people, and one person is typing in the code, and everybody is thinking along how to write the code in the best possible way. Is this a waste of resources? Well, maybe not, because, well, imagine if you need to build a new piece of software, you're not exactly sure how it should be built, which architectural patterns should be followed, and you want to prevent a lot of refactoring, and you want to make sure that you're aligned as a team, and you will also would like to make sure that the junior team members understand the thinking process. The mob programming can be a really nice practice to build certain aspects of the functionality that you want for a program. Maybe not for everything, maybe not for straightforward parts, but for new pieces of software, it can be a really nice and interesting approach. We also see that security becomes far more important. Well, maybe we used to trust the boundaries of the organization, that within the firewall you had different security standards. Well, now we want to make sure that we take security really seriously at every level. Then the last practice I want to mention, maybe something for Ida to talk about a little bit later as well, is shift left. Think about quality from the first moment you think about specifying what you want the software to do. One of my last slides, Google has done a lot of research in how you can determine if teams are productive. Because if we let go of ideas of Scrum and Waterfall, how can we know that the team is actually productive? Well, what the research from Google found out after a 7 years research program, that there are four key factors that give a good indication about the productivity of your team. How fast can you implement from idea to working functionality at the change lead time? And also, how fast can you go to production? How fast and how frequent? And if something goes really bad, how fast can you fix the system? What's the mean time to restore? And also, how often does this happen? So these are four things that you can measure quite easily and gives you a good indication about the productivity of your team. And I would say these are far better ways to determine if a team is productive compared to story points, which is, of course, a very subjective approach that's also valid only within a team. So I think this is a really nice way to maybe see if your team is productive and also investigate how you're doing. That was my presentation. I think we're going to do questions after.
Yes, I'm joining you here. I did not receive many questions in the chat, although your presentation is really, really interesting, and there are a lot of opinions in your in your presentation. So thanks for that. And just to challenge you guys a little bit, I made a small poll for the break. So when you grab your cup of coffee, I'm very curious if you guys can reflect about one thing Roy said, and maybe you come up with a lot of more questions, but you told us about maybe it's time for the comeback of the Monolith.
Yeah.
And I'm very curious what you guys think about that. So maybe you can share your answers in the chat. We are a little bit upfront on our scheme. That's no problem, I think. We will continue at 10 to 8. So enjoy your cup of coffee. If you have any questions, please drop them in the chat, and we will see you at 10 to 8. And let's see if I can. Zoek ik eigenlijk die presentatie. So I think we're perfectly timed at this moment. And I put the camera back on. So I saw some reactions in the chat, and sorry for the persons who couldn't react to that because they have an external connection. I will send the questions and the results of the poll. Of course, I will send that in the follow-up email. We have a tight schedule, and Roy talked a lot about technology. He also had some heavy opinions, maybe, about working together in an agile environment or DevOps environment. And Bert-Jan, our next speaker, told me, like, it's nice to talk about technology, but you can really fuck up if you don't give the right attention to people and processes. So Bert-Jan, I would like to invite you here at the stage because you are going to tell us a little bit more about the best principles in CI/CD, right?
Thank you. Yes. So let's get started. So as I'm introduced on the slide here, I am a Chief Troublemaker Officer at Open Value. And it's nice to see that Roy, our director, who's supposed to be the least technical one, still is telling a technical story, and I get to talk about less technical stuff. So in the next 30 minutes or so, we're going to be talking about the principles of continuous delivery and DevOps. And as we already briefly discussed before, all the technical stuff that Roy talked about, you can get it all right, but if you get this wrong, you still have nothing. So I recently passed the mark of being 42 years of age. And once you reach a certain age, you start looking back at your life and thinking about how everything was better in the good old days, right? But I think that in software, we can actually spin this around, because in the good old days, we didn't have clouds, we didn't have build servers, we didn't have much test automation tools. So in the good old days, if you wanted to start building the next big app that was going to get hundreds, thousands, millions of users, you needed to start with money to buy hardware. Nowadays, we have cloud environments and automate provisioning and even Kubernetes, where you can start small and pay little and scale out big when you gain a big user base. So let's start with some definitions to get each other started on the same page. So the core of CI and CD, well, what's funny is if I ask people what CI and CD means, then we basically typically agree on what CI is. It's continuous integration. But once we talk about CD, it becomes a bit more vague. Is it continuous delivery? Is it continuous deployment? Is it continuous development? That sounds pretty cool. Continuous development. You're only developing continuously. You don't have any meetings. You don't need to design. You're just developing. Well, if I'm talking about CI and CD, I'm talking about continuous integration, continuous delivery, and continuous deployment. So let's start with the first one. Continuous integration basically means integrating your work frequently. So the team members integrate their work by committing into version control, and their commits are verified by an automated build and automated tests. Then continuous delivery, I'd say, is more of a way you approach delivering software. So it's about building and testing software in such a way that it's always releasable. You don't necessarily deploy every change to commit to production, or you deploy every release to production, but it should always be releasable. You should always be ready to deploy to production. Then there's continuous deployment, where you're actually deploying every change automatically. So once a commit gets verified by your CI, your automated builds, by your automated tests, it automatically gets deployed into production. If it's not every change, it's not continuous. If it's not in production, I wouldn't call it continuous deployment. And then my favorite, DevOps. So what is DevOps? Well, the answer is nobody knows, because if you ask 1,000 people, you get 1,000,000 definitions. So we'll dive into DevOps in just a bit. But first, let's stay with CD. So what is the goal? Well, why should we do this? It's about releasing software. So it's about getting software out there in the hands of your end users. And it should be repeatable, and it should be reliable. If it's not repeatable, then it's a one-off. Doesn't really make sense. If it's not reliable, then you're not going to do it often, right? So it's about a process for getting software out there in the hands of your end users. So what are now kind of like the principles of continuous delivery? Obviously, it's about automating, because you want to make things reliable. You want to make them repeatable. Then automation makes sense. Automate as much as you can. Keep everything in version control, so you know that who changed what when, and preferably you also know why. If something hurts, do it more often. If something hurts you in getting your software out there in the hands of your end users, it's something you need to improve on, it's something you need to practice, it's something you need to improve your processes or your automation. And obviously, if you're going to deploy to production often, then quality matters. Because if you have quality software, this is the only way you're continuously going to be able to deploy your software to production. If you don't have quality, things are going to fall over and you're not going to have a repeatable and reliable process. This is one of my favorite ones. Done means released. So if you're working in an agile way, as we've learned before, your chances of succeeding are highest if you're working in an agile way. Then you typically have a definition of done. And this definition of done describes whenever you're ready to mark a story as done. So I'd say that the story is not done until it's released. And what released means can differ per organization. But in general, I'd say it must at least be installed on some test environment, preferably even in production, but I'm okay with test environment. Because not until you install to a test environment, you know that it actually works, that you have run the database scripts that are necessary, that you have made any configuration change to your environment or even deployed new environment. So done means released and preferably released into production. And everybody's responsible for the delivery process. So it's not just the operators or the system administrators or the developers. The whole team should be responsible for getting software out there in the hands of your end users. So it's a team effort. And obviously you want to focus on continuously wanting to improve yourself. So preferably every sprint or during a sprint, you look back as a team, you say, okay, what did we do? What went well? What could we do better next time? And you actively work on improving those things, therefore becoming better and better at every iteration of your product. So, what are the ingredients that we that we need to apply these principles? So, I'd say they fall in 5 categories, and we don't have time to go in detail of all of them, but I'm going to shortly dip into each of these categories. So, the first one is culture and organization. So in terms of organization, I'd say that an agile way of working works well with continuous delivery because you have short iterations, developing and delivering usable increments of a product in every iteration. It's about building the right thing. So building something that your end users can use to make their day job easier. It's about building the thing right. So this means focusing on quality and actively reducing technical debt. It's about having cross-functional teams. So a team has all the capabilities it needs to go from idea to working software in production. And it's about having room to experiment and room to fail. Because if you have room to experiment, then there's opportunity for learning. If you are afraid to experiment because you're afraid of the consequences, probably that's the culture thing, right? If you're afraid to, I don't know, break production by an experiment and you're afraid that your boss is going to get mad at you, well, that's a culture problem. So what I typically say is try to find a way of working where you have room to experiment and where you also have room to fail, because failure is where you learn. There are companies where you get that order cake for the biggest failure of the week, where you get the best parking spot if you had the biggest failure. I sometimes get the question, yes, we're working agile and we have self-steering teams. And what is the role for a project manager in a situation like this? So I say, one of the roles of a project manager is to create a situation where it's okay to fail, where it's safe to fail, where you don't get blamed for something that goes wrong, but as a team you sit together to see what should we do better next time when we fail at something. You need to become good at failing. So if we move to the second ingredient, design and architecture. I think obviously a big part of design is modularity. Being able to deliver small parts of your product. If you're building a bigger product, you shouldn't need to deliver the entire product at once. If we look, for example, at Netflix or Spotify, they're not deploying entire Spotify to production once a day. They're deploying all small parts of Spotify to production 1,000 times a day. So there's one team, for example, working on search. There's one team working on recommendations. There's one team working on album covers, just making it up on the spot. But these small parts can be delivered independently of each other. And I think that's the key to speed in any organization, small or large, independence. Independence between teams, independence of software components on versions, independence between stuff that different teams build. So as long as you cut away any dependencies you have, every team can move at their own pace as fast as they can and want to go. It's also about designing for failure. There's one thing you can know for sure, things going to fail. It's about thinking stuff like, what's my branching strategy going to be? Then the next ingredient is about building and deploying. And in continuous delivery, there are two pillars of building and deploying. Well, actually one pillar with two different views. It's pipelines. So a pipeline is basically a set of steps, a sequence of steps to get software from version control into the hands of the end user. And I typically like to split these in two. So one part is your build pipeline. Build pipeline takes a commit from version control, builds it, tests it, and the result is a deployable artifact, being a zip file, a jar, a tar file, anything that you can, a Docker image, anything that you can deploy. And then the next step is the deployment pipeline. This picks up where the build pipeline stops. It picks up the deployable artifact and deploys it to a target environment. So why should you split these two? Because ideally you build a version once and then you deploy the same binary version to all your environments. If you have a specific build for your production environment, then you're basically deploying untested software. Obviously, it's probably the same commit or the same tag, but it's a new build, it's a new binary that you haven't tested in any environment before. So build once, deploy many. If we're talking about test and verification of your application, it's obviously about having a test strategy. So which tests do I use to test what? Do we have unit tests, integration tests, end-to-end tests, acceptance tests, performance tests, security tests, UX tests, usability tests, and there's probably about 10 more. Testing non-functionals and verifying expected business value. So a short story about verifying business value. This is something that's fairly hard to measure, right? How do you test that the thing you build helps your end users use your application or do their job even better? So I remember when I was working for, I think, a Dutch police, and we had a product owner that had a fairly specific ideas on how things should work. And there was this feature that we had the idea that was hardly used. And we told to the product owner we were going to remove this feature because it was only causing us a maintenance burden. And then he said, no, I'm pretty sure that this feature is used a lot, so please don't remove it. And then we said, okay, we're not going to remove it yet. So then we secretly built some metrics to track how often this feature was used. So after 2 weeks, we went to the product owner and we said, yeah, we're going to remove this feature because it's hardly used. He said, no, you cannot remove it. I'm pretty sure that it was used at least 10 times in the past 2 weeks. And then we said, yeah, you're right. It was used 12 times in the past 2 weeks, but only by you to demonstrate that this feature was used a lot. So if you don't have these insights, then you don't notice. So having usage metrics helps to get an insight of, does this feature actually help my end users accomplish their goals? And then information and reporting, kind of where my story was going, you need to have insights on how is my system being used. So you can have stuff like automatic change logs, so you don't have to type your release notes by hand, metrics on system usage, monitoring, dashboards, anything you can use to gain insights on how is my application being used can help you on understanding your application better and how it's running. So we're about halfway, and this is where we're going to make the cut between continuous delivery and Devops. Here you see one of our developers who has just deployed something to production. And as we see, it's all working. It worked fine in development and in production. The ops guys and girls are now fixing everything that went on fire. So if we plot continuous delivery to DevOps, let's first look at definitions. So the first one is that obviously it's about devs and ops, and it's about devs and ops being responsible together for the entire life cycle of a product. So it's about taking responsibility for something from beginning to end. It's a shared responsibility. What we could also say is that it's about developers and other IT professionals who are working together on a shared goal. And this shared goal is basically running software better and faster. It's about running better quality software quicker and more reliable. But today you get even 3 definitions from me. So another one, and this is a bit more goal-driven, defines DevOps as a set of practices with the goal to shorten the time between committing something and having it being placed in production, while also having the highest quality possible. So it's about getting a commit in production as fast as possible with the highest quality as possible. So why should you do all this? Well, because it makes your business move faster. It helps your business win. It is an enabler for continuous delivery. It helps you to resolve problems faster and to focus on adding value instead of focusing on resolving problems all the time. And I'd say that's not about something new. DevOps is not an entirely new concept. I think it's something that we did wrong in the past. So if we move way back, I don't know, 30 years ago, there was no distinction between developers and operators. Everybody was doing everything. And then we got expensive servers, and these expensive servers needed specialized personnel to maintain these servers and wanted to maximize the return on investment for these servers. And this is where we started splitting devs and ops. And I think now servers are not expensive anymore. Hardware and even cloud resources are a commodity. So it's now about fixing this mistake from the past and getting those different expertises together again. So principles again, but now for DevOps. It's about making gradual changes. So making lots of small changes instead of a small amount of big changes. It's about being customer oriented. So building stuff that the customer wants and needs and solving actual customer needs with the software that you're building. It's about automation, obviously. It's not a goal of DevOps, but automation helps to build stuff quicker and more reliable. It's about having and taking ownership. So if I'm responsible for running an application in production, I can only take this responsibility if I also have the ability to investigate and fix things when things are wrong. So one of the early discussions I had about having access to production for my application was with the previous operators. And I said, I need access to production. And they said, well, you're not going to get it, because if you have access to production, then you can break things. I said, well, let's turn it around. If I don't have access to production, I'm not able to fix things. So I'm not able to take the responsibility of running this. You want me to become responsible, then I also need to have the power to fix things. And obviously, you don't always need production access to fix things. You need a mature set of tooling that allows you to fix things when things break. So reliable deployment tooling, reliable metrics, reliable debugging tooling. So if you're mature enough in terms of operations, then you probably don't need production access. If you're just getting started and all you have is SSH to a production environment and typing commands in a terminal, probably you do need production access. Obviously, it's about collaboration, collaborating within the team, with your end users, with the business. You want to build something together that makes sense. And there's experimentation again. Experimentation gives you insights that you otherwise wouldn't get by just thinking. So I remember a situation where we had an application that would go out of memory every couple of days. So, well, basically there were two ways to solve this problem. One was to start thinking and keep thinking until we figured out what the problem was, indefinitely maybe. And the other was start experimenting. And we chose to go experimenting. So we split our production cluster, which was a cluster of machines, in two. We tried out one memory configuration on one end and one memory configuration on the other end. And we saw which of those configurations kept running for the longest. So then we knew that this was a better one, and then we iterated from there. And after a couple of days of production crashing off and on, which didn't matter because there was a load balancer up front, which would detect when a node was up or down, we had found a configuration that didn't break anymore. So did we know what we were doing? Not really. Did we solve the problem? Yes. So this is what experimentation is. You don't necessarily exactly know what you're doing, but you're trying out things and trying to make sense of the outcome of your experiments. And here's continuous improvement again. Obviously, you do continuously want to look at what am I doing and what can I improve. So you see that lots of the principles and ingredients are comparable between DevOps and continuous delivery. Although I'd say that continuous delivery is mostly about how your software delivery process is implemented. And I'd say DevOps is a bit broader. It's more about how, as an organization, do you strive to have the best quality software from commit to production as quick as possible. So if you want to know more about DevOps, I cannot tell you how to do DevOps right, but I can tell you how not to do DevOps. So here are 15 misconceptions, call them anti-patterns of DevOps. So the first one is it's exactly the same as continuous delivery and continuous deployment. Well, I'll happily point you to the slide I showed 10 minutes before. I'd say continuous delivery and continuous deployment are approaches how you deliver your software. DevOps is broader. It's about running your stuff in production also. So everything I'm going to share now is false. So just make sure to watch at the part that says failure on top. Don't share these slides without the header, otherwise I'll get in trouble. You need a central DevOps team that handles all ops stuff. Well, DevOps is about removing silos. So before you had devs, you had ops, and you want to get those two silos to work together. So if you now add a DevOps team, you're actually making it worse. You now have 3 silos. So as Roy explained, you can have a platform team or a developer experience team that builds tools that all the other teams use. But in general, I'd say a DevOps team is a team that's end-to-end responsible for one or more applications. Don't go by adding DevOps teams to your existing setup because you're only making it worse. It's only for devs and ops. Well, I'd say the whole team is in. Testers are in, UX designers, even project managers. If you give a project manager a button to deploy, they're happy to press the button and to deploy a new version to production. It means developers managing production. I'd say no, or yes, or it depends. If you work for a bank and there's 3,000 developers, probably not everybody's going to get access to production. But if you were a startup bank that has 3 developers, probably everybody needs access to production. Otherwise, things are going to explode when 2 of the 3 are sleeping or are on holiday or are at the toilet. So it's also a matter of managing risk, right? It's harder to manage risk for 3,000 people than for just 3. So I'd say it depends on your situation and also on the maturity of the tooling you have surrounding your production environment. It's only for hipsters and startups and unicorns. Well, I'd say that it can work for the enterprise too. I know fairly big financial institutions who do DevOps. It's surely easier for hipsters and startups and unicorns because they're typically smaller, but it can work for the enterprise too. If you're just getting out there and just getting started, it's definitely easier to get started with DevOps right away than to transform an existing organization, but it is doable. You need containers and microservices and the cloud to do DevOps. Well, I'd say it's not about technology, it's about collaboration, about culture. And I would actually turn this around. If you're doing containers and you're doing microservices and you're using the cloud, then you better do DevOps. But you can definitely do DevOps with a bit, well, let's say more traditional technology. It's about automation. Well, we discussed this before. Automation helps, but it's not a goal. It's a tool of succeeding in DevOps. Talking about tools, I've heard people say we're going to get Chef or CloudFormation or Bitbucket, and then we can do DevOps. Well, you don't need to do any of those tools. Obviously, those tools help, but I think it's more about the process and the culture and the mindset you have as a team. So there's a quote from Grady Booch from IBM, and he says, "A fool with a tool is still a fool." And I can't help thinking about B.A. Baracus from the A-Team whenever I think about this quote, but I think the quote really makes sense, right? If you have a tool, you can still be a fool with it. And then one of my favorites, it's the job title. I hope not many of you have DevOps certifications, but I don't really believe in this. Can you be certified in DevOps? I wouldn't say so. Or actually, maybe you're all certified because DevOps means working together, right? So you all learn this in kindergarten when you learn to play and cooperate with the kids in your class. So, well, probably you can say that you're now all certified in DevOps because you know how to work and how to play together. DevOps replaces Agile. Well, I'd say that Agile is a way of managing development of software, and DevOps is broader. Obviously, they work together pretty well because they both focus on working in small increments and continuously improving. But I say Agile is more of a software project management methodology, while DevOps is more like a mindset and a culture. It doesn't work with Waterfall and Prince and ITIL. None of those things work with DevOps. Well, that's like saying collaboration doesn't work with Waterfall or with Prince or with ITIL. Sure, it works better with Agile, but you can do DevOps in a Waterfall setting as well. This one I explored firsthand. So there's no need to define what DevOps means to your organization. I did this and it didn't work. So I was going to do DevOps in the organization, and then I was on the phone with a project manager, and the project manager didn't understand anything of what I was trying to do. And then I got a bit mad, and he said things to me like, I want to be serviced by DevOps, and I want to call DevOps when my application is down. And then I hang up, and I was a bit frustrated, and I said to my colleague next to me, like, this guy doesn't understand anything of DevOps. And then he said, well, did you explain it to him? And I said, no, obviously I didn't. Maybe that's the problem. So there's also a story about, I think, a bank in the Netherlands who said, we're going to do DevOps from January 1st. So January 1st, well, it was a holiday. January 2nd, a developer walks to the operator and says, give me access to production. I said, no, you're not going to get access to production. Yes, we're doing DevOps from January 1st, so I want access. No, but that's not what DevOps means. It is what DevOps means. And then the management didn't tell what DevOps meant and what they meant with it. So in the end, there didn't come an answer to the questions. So I think a couple of developers tried to do like a survey to get some kind of understanding what DevOps would mean for the organization. Typically, it works better if you do this beforehand, and then you can tell it to everyone. And as a result, it's obviously fairly hard to do DevOps without having buy-in from management. So you're going to change an organization, change how the organization works. Not everybody may agree with what you're going to do. So if you tell somebody to do something, and I said, I don't want to do this. You say, you need to do it. They say, no, they're going to talk to the manager. This manager is going to talk to their manager. And in the end, somewhere higher up the tree, somebody needs to say and shout back to them, no, we're going to do DevOps, so this is how you're going to do it. If you don't have any buy-in from management, then probably it's not going to work. And as a result, you can never enforce DevOps in an organization. It's a cultural change, and you cannot enforce cultural change. You need to explain where you're going, why you're going there, and what it means for everyone, and what this will mean in terms of how your job will look like and how things will change in the future. And this is hard. This is one of the hardest things. Changing technology is easy. Changing culture is hard. And then the final one is that DevOps prevents failure. I remember in an earlier DevOps transformation I did, one of the head of system administration came to me after we were doing DevOps for a couple of months, and he said, I have statistics here. And I said, that's great. Statistics gain insight. And they're not looking good for you. I'm like, okay, so what's going on? Here are the statistics of downtime before we did DevOps. And there was hardly any downtime. Here are the statistics of since we're doing DevOps. There was 3 times as much downtime as before. And I said, well, that's great. I said, why is this great? This is horrible. We're having 3 times more downtime than before. So yeah, well, that means we're learning. So before it was all static, and we had 1 deployment per month or something. And now everything was dynamic, automatically scalable, and we were doing 1 deployment per day. So I said, okay, so we've now done 100 deployments, and we only had 10 hours of downtime. So that's 0.1 hour of downtime per deployment. Before, we had 2 hours of downtime per deployment. So in essence, we became way better. So we didn't really agree there, but in the end, it became better than it was before. But obviously, once you're getting started and you're changing things, at first things will become worse because you're learning and you're growing as an organization. So what is DevOps really about? And I'd say that's mostly about culture. It's about reinforcing culture with technology and vice versa. And it's about collaboration, cooperation, communication. It's about being agile and continuously wanting to improve yourself. And it's typically a culture of freedom and responsibility. So freedom is nice, but the price you pay is responsibility. So take responsibility, trust your teammates, and design a system in which people are being held responsible for the consequences of their actions. Create cross-functional teams. As Werner Vogels, the CTO of Amazon, says, you build it, you run it. So you should also be responsible for operating the stuff that you build. And I think finally, it's about empathy. It's about caring enough about your job to want to learn all the parts and not just your little world. So empathy, which basically means placing yourself in somebody else's shoes. It allows you to view other teams as enablers rather than as blockers. So my general advice for anyone in tech is be likable, be approachable, and get stuff done. So is that it? No, because I hear you think, that all sounds great, but it won't work here. Because we are regulated, or we're not building websites, or we have too much legacy, or my favorite, our people are too stupid. So let's start over with this slide. We're regulated. Well, Amazon is regulated, and they're doing a gazillion deployments per day. So if Amazon can do it, I'm not sure if that's a good comparison, but if a regulated company can do it, then you can do it probably as well. We're not building websites. Well, that's fair. It's probably easier if you're building websites, but HP is doing continuous delivery on their LaserJet firmware. So if it can work on the printer, it can probably work on your application as well. We have too much legacy. Okay, that slows you down, obviously, but there's ways around this. You can, for example, apply a strangler pattern where you basically wrap your application in something new and then gradually pick out parts that you improve. It's more difficult, but it can definitely work. And then our people are too stupid. Now, there's a story from, yes, takes about 1 minute, and I have 1 minute, so it should work. There's a story about a car manufacturing company. This was the NUMMI factory in Fremont, California, part of General Motors. And this was known as one of the worst performing car factories in the whole of the United States. The employees would generally show bad behavior. They would show up late or not at all. They would get drunk on the work floor, and they would mess with cars they were building on purpose. For example, put glass Coke bottles in the door of the car, so they would make a rambling noise when you'd open and close the doors. And no surprise, this factory went out of business because they didn't do so well. And then Toyota came in, and Toyota wanted to use this location. And actually, this is now where I think Tesla is building cars now in Fremont, in California. But Toyota took over, and then, well, they wanted to bring in their own people, but then the car union said, no, you need to hire at least 85% of the troublesome workforce. They rehired those people. They sent them off to a training camp to learn the Toyota way. They gave everybody a nice uniform. They started treating everybody nice, gave them nice perks, good food, good parking places. And slowly the factory started performing fairly well. And after a while, the factory started performing really well. So after a year or so, the previous management from NUMMI met the management of Toyota. And then NUMMI said, yeah, so the problem was the people, right? And then Toyota said, yes, the problem was the people, but not the people you think. So in the end, the problem was the management. The way the management was treating the people reflected in the performance of the factory. So with the same people and treating them better, Toyota managed to get a quite well-performing factory. So actual reasons can be that, well, there's something wrong with your culture or there's something wrong with your architecture. Both of these things are changeable. They can be hard, but it is doable. So why should you do all this? Well, because it helps you reduce errors, lowering stress. If deployment is a non-event, you're going to do lots of them. And it empowers teams to become responsible for the application they're building and managing. And gives you deployment flexibility, so you can then deploy whenever you want. And in the end, practice makes perfect. So how is the final question to answer? Well, it's easy. You just say, let's spend the next few months working on improving everything, our builds, our automated testing, our infrastructure, and do not develop any new features for the next couple of months. This is a famous quote from no product manager ever, because you cannot close your store for a couple of months, right? You need to keep your shop open. So how I generally approach this is fairly simple, lots of small steps. So start small. Take one thing that you're pretty sure that you can improve. Show the results. So when done, share them with your team. Celebrate. Wow, we did a small thing and now it saves us 1 minute every day. But if it's 1 minute for 10 people for a year, it's still significant. And then iterate from there. So tackle the next issue and keep improving. And in the end, well, as you see here, your tree will grow. So to summarize, why are we here as software teams or software developers? I say we have one single goal, and this goal is having working and useful software in production. If it's not working, it doesn't make sense. If it's not useful, it doesn't help our users. If it's not in production, it doesn't help our users. So all these three things are necessary. And as far as I'm concerned, there's only one way to accomplish this, and this is continuous delivery and DevOps. That's all I had to share. Please take your advantage with these little things. I think we're going to take questions in a bit, right? Thank you.
I think so. Maybe we can see all people on screen.
Yes.
Perfect. Yeah. And I would like to invite Ida as first. Ida Koops coming
Yes.
in all the way from Haren, Groningen, back in the north of the Netherlands. I asked you to reflect a little bit on the quality part, because we heard a lot about technology. We heard a lot about process.
Yep.
Ida, you as a QA enabler, what do you think of the stories of Roy and Bert-Jan?
Well, I think it's I hear myself double talking about quality. So
We'll turn you down.
yeah, this is better. Well, I think this was a very how do you say it? It was a good story about the things I experienced the last, I think, 50 years working in quality. The industry made a change, and we also, from a testing perspective, from a quality perspective, are also changing along. And it is really about continuous improvement, providing continuous insights. And that means that it is changing from checking for quality after something is being built to take quality into account from the start. So build quality in, and I've heard Bert-Jan say it, and think as a tester or as a member of a team, which stuff can you do to address quality and to really pinpoint on the things which matter most. And I think, in my opinion, to make a change between those two is think early about risks. What is the stuff which threaten your value? What's threaten your business? Because if you don't find those risks during development, it became a bug, or it became an incident. And that's all where DevOps, where agile working, where the whole continuous improvement loop is about learn, prevent, and improve. And that I think is really changing our job. And that's also why we are not calling testers anymore, because testing is really small. But it's more about QA engineer, QA DevOps engineer, and for the more supporting people, it's more QA DevOps enabler. And I think we are changing on that, and I think the whole world is changing on that.
Thank you, Ida. And I'm very curious, maybe you can kick off, because we have changed the setting already a bit. I don't know if you could all hear me. We have Roy and Bert-Jan over here for our Q&A. I will take the microphone to that place as well. But I'm very curious, do you have a question for these two guys, or one of these two? And if not, I will move on to Sander, because I know Sander always have questions. This time not.
Oh, it was a pretty clear, summary of a lot of things we all think know a little bit. So sorry, this time I can't help you with a good question.
No question from Sander. Thank you for visiting. But then again, who is in the room and who wants to ask a question to Roy or to Bert-Jan?
Well, I have a question.
Perfect.
So at some point, I think Roy, he mentioned the monoliths coming back, but he also showed a slide about bigger projects having a lesser chance of success. So how would that work? Are we moving towards, well, less successful projects?
Yeah, that's one way to look at it, for sure. The point I was trying to make, it's always a good idea to build applications in a modular way, where each part of the application has the least amounts of, interactions, dependencies with other parts of the applications, right? And you have a clear interface between different parts of the application. And microservices, they tend to force you to think about this, because you want to offer a REST API or GraphQL API that enables other services to communicate with that microservice, ideally through an API gateway, for instance. With that way, you hope that you can more easily replace certain services or maybe change the logic in the service without affecting the entire system. And what I try to advocate is what you see a lot is that teams make shortcuts. So there are a lot of microservices out there already, and you need to quickly build an application, and you maybe circumvent the API gateway, or maybe you need a lot of different microservices to actually make the application perform a certain thing. And if you then change one of these microservices, well, the functionality doesn't work anymore as expected, because you are having some side effects at other places that you did not expect. Basically, you're back to the problem that you had when you had these huge monoliths from, well, usually the 90s or the zeros of the century. And if you would say, well, these microservices, the idea is really great to build software in a modular way, but why not put all the services on the same server and make sure that you have, well, a really good branching strategy, that you have really good pipelines with lots of quality checks, that you build every function in a really modular way, maybe also apply principles of functional programming to reduce side effects. And if you do all those things in a really, really good way, well, you can also just build a monolith instead of a distributed landscape with all kinds of microservices. And you don't have the network overhead, causing you all kinds of extra complexity, and also the performance hit that you have. You need a lot more resources. So it's always better to build a monolith if you can build it in a really neat and clean way, right?
Yeah.
So that was more what I was advocating. Yeah, I hope I answered your question.
Yeah, I figured something out, but the explanation is really nice. So yeah, thanks.
So
Thank you, Daniel. I saw also a question from Oliver. Oliver, maybe you can come in and tell us a little bit about your situation.
I can try. So
Welcome.
a lot of the software we build is medical device stuff, so heavily regulated. Obviously, that means we can't do DevOps, right? So I guess what I'm trying to work out is how we could best apply DevOps practices, because a lot of the guys that buy our software will perform their own validation on each deployment, so they don't really want a daily deployment. So I guess I'm kind of interested to know what your advice would be in that kind of situation.
Yeah, it's a great question. So one metaphor, well, not really metaphor, but what I typically use when talking about problems in software is, well, there's a commercial application and somebody screws something up, and we go down for 5 minutes, for a half hour, for an hour. And then, wow, there's a big panic because we're down. And what's the result of being down? Our users are unhappy. That's one. So people are unhappy. And we're losing money because we're not closing any sales while we're down if we're an e-commerce application, right? And then to put stuff in perspective, I typically say, well, if we look back, we were down for half an hour. We lost maybe, I don't know, X amount of sales that we couldn't do. But we were back up. There's no lasting damage. There's no data that's corrupted. And nobody died because of the downtime. But the last thing I said is different in your situation, right? If you screw up something and you make medical stuff, then people's health can be at risk if you do something wrong. So obviously there's lots of more of formal validation going on, because you want to really make sure that the software you're writing for these medical devices is not going to screw up somebody's health. So what can you do there? In the end, it's about getting software as quickly as possible from inception, idea, to being installed and ready to use for your end users. So if say that you're building software for an MRI scanner, then the end user probably is the technician operating the MRI scanner in hospital somewhere. So then you can think about what's my complete path from idea. We're going to implement a new feature. And what part am I going to travel from there to my end goal, so my MRI scanner? And it's not much different if you're writing software for example, for the Ministry of Defense that's being used in on battlefield, because there typically it's also a bit harder to get it to, I don't know, some device that's driving somewhere in the battlefield that's air gapped in some way, and you screw something up there, then also people can get killed. So I think the point is to knowing your constraints, still trying to optimize the independence of the software that you're building, and trying to optimize the path from idea to building this, testing it, releasing it, and deploying it. And in terms of, I did a workshop for the Dutch Air Force, and they had this problem, right? They said our production environment is air gapped, and we need somebody to copy stuff on a USB stick and then install it, take it to the other machine and install it in production. And then I talked to them like, how can you improve this? In the end, we came up with a solution where there were 2 computers physically located as close together as possible, so that the actual deployment time was not limited by how fast the person could walk from one computer to the other. And then try to automate the deployment process as much as possible by, as soon as something is built, sending a signal to somebody, okay, you can now take the stick, it's already copied in there, bring it to the production machine. Or maybe even plan this, that you have a deployment window every day at 2:15 p.m. Or something. In the end, you want to automate the path from idea to production as much as possible, and also try to minimize any wait times you have in there. So this is about removing waste. So obviously you're not going to get as close as doing a gazillion deployments a day like Amazon does, but you can think really well about what of the parts that are costing time in my process can we automate and improve. And but you can only automate and improve what's in your own reach, right? So if you're limited by the speed of working from an external IT department from an external hospital, that's something you probably have a hard time influencing. But also there you can maybe think about how can we make their life as easy as possible by installing our software. But surely it's harder than in a web application for an e-commerce company.
Sure. Thanks.
It's a nice example, Bert-Jan, about how you can minimize the time.
Yeah.
I never thought about that. So maybe that inspires another person for a question as well. I see it's quite quiet on the chat. And I see someone's coming in.
I can go again if no one else wants.
Well, if I may, over here at BCT we have several products. The one which I would like to talk about is the Libre platform, and the problem there is it's all a lot of on-premise. So a lot of customers have their own installations, even multiple database systems, Oracle, MySQL, and yeah, you can't force them to update. So there's requirements for patching old versions, and also it's Windows and Linux. So even the deployments aren't the same. It's really hard to actually apply the DevOps there. I mean, some concepts can be done working together on parts, but to really implement it, is it even possible or feasible to do it that way, or should you try to convince your customers to move to another way of working? It's really hard to apply it.
Yeah, it's also a great question and well, a great situation. Obviously, it's easier when you have everything in your own hands, right? So if you control everything from your laptop to your production server, then you have influence on this all. The first time that I discovered the value of DevOps is long before the term DevOps was coined. I was building software for an insurance company, and there was an external hosting company, and we would send stuff to them to deploy on their server, and then they would or would not get it working. And then we would typically make fun of them because, well, the stupid ops people didn't understand our perfect software. Well, they sometimes made stupid mistakes like copy pasting a configuration setting and then not checking that it would end with a space. How stupid are they? That was our well, let's say our arrogance at the time. And then things changed, well, in 2 ways. One way was when first we had a big project and the hosting company didn't have enough people to do the ops work for this project. Then some of my own colleagues went to work in the ops department. And then after 2 or 3 weeks, everything was going really smoothly. And then I said to my colleague, wow, everything is going a lot better now that you are doing this. And then he said, well, you should know the amount of rubbish that you're throwing like throwing over to us, and the amount of work we need to do to get it working. I said, but you're getting it working. Yeah, because we've been building this application for 3 years. We know how it works. But the problem is the rubbish you're throwing to us with inadequate instructions, with non-working scripts. So it wasn't the stupid ops people. It was us, the arrogant developers, who were incapable of writing clear instructions to them. So this was, I think, point one. And the second one is when I first started working in this situation, I also noticed that sometimes things would go wrong during deployments. And I was curious to find out why. So I went to set with the hosting company, see how they were working and how they were deploying our stuff. And in one evening, the guy had 20 questions for me. They were all valid questions. And this made me think, wow, is it their problem or is it my problem? And by sitting together during those deployments, not only did we develop a more friendship-alike relation, which made working better and easier, but also I got to see a bit of their world and they got to see a bit of my world. And this is, I think, the empathy part. So because we got to understand each other better, we also could work together better and deliver, from a customer perspective, better quality service. So I think you can apply the same principle if you have stuff that's hosted by your customers, by visiting them every now and then, seeing and trying to understand what their problems are with installing and maintaining your software, and see if there's a ways where you can help them become better at it, or change your product or your deliverables to make it easier for them. Maybe think about tools that somehow can automate their work. Maybe they want to improve, but they don't have the capability to automate their work. So I think in the end, all hands that touch software from inception to production is a place where you can improve. So if you, as a software supplier, end your responsibility once you deliver to your end user, to your customers, and then they still need to install everything, and they fail at installing it, well, it's your problem as well, because from the perspective of your customers, the software is not working. So I think your responsibility as a supplier doesn't stop when you deliver your deliverable, but it stops once your deliverable is running successfully on their infrastructure as well. And obviously it's not easy, but I never promised that it was going to be easy.
Yeah. Okay, thank you.
Thank you, Frederik. Ide, I see you had you shared something in the chat, but you can come in by using the microphone as well.
Yes, well, thinking of the last case, and I've seen that at one of our customers. What always is a good start is to find out and discuss also with your customers what's causing the complexity we are running into. Different clients, different systems, all that kind of stuff. And which things can we think of together? So together with your customers to solve that one. Because if you get the buy-in of your customers, because some of those also see this is a problem, because they want new features faster, and they want also to reduce the cost of your software system. So then you can get the buy-in of all your customers or some of the customers to make that improvement, to build a new system with the new architecture, to make the new delivery process, and to make it working together to archive that goal. And that way you can experiment and learn from each other. And that's really helping, or I saw it happening, improving that part. So go talk to your customers and find out what's been needed and try to solve that complexity.
Yeah, and the fun thing is sometimes it's not even your fault, it's not even your customer's fault, but it's something else. I recall I was building e-learning software and the customer complained the software was running slow for their students. And I didn't figure out what was wrong until I went there. I had them show me their laptops, and images were loading slow. In the end, it turned out that they were running on a dual internet connection that was switching back and forth now and then. Still was pretty fast, but because they had two connections, they couldn't use their DNS server from their provider, and they used Google DNS. And it turned out Google DNS had some kind of a rate limit that slowed everything down to a grinding stop. So the problem was not caused by our software, maybe by the setup of the customer, but from our end user's point of view, the system that we were delivering was slow. Yes, sometimes you really need to sit down together to figure out what you can improve.
Nice. So it's about not only collaboration in the team or in the teams in your company, but it's also about collaboration with your customers.
Yeah, it's about everything between you and the end user of what you're building.
Nice. Oliver, I see you chatting that Roy mentioned the agile world for better alignment with DevOps. Would it be a Kanban type of approach, Roy?
Yeah, I would definitely say that idea of having like a maximum amount of items that you pick up at the same time and managing flow definitely suits the more DevOps type of approach, because you just try to deliver functionalities, you try to solve bugs as fast as you can in a controlled way, without any kind of contract that you will finish at least this or that functionality in a specific time frame or time box. So for sure, I see a lot of teams switching to Kanban, and they all feel liberated because you can do all these Scrum sessions and maybe do a stand-up in the morning and try to determine the sprint backlog, the retros and so. But most of the teams that I know, they're really fed up with all these sessions because they don't get any value from it. They continuously talk to each other because maybe they're doing mob programming. So if you're talking with the entire team all day, it's really crazy to do a stand-up. It doesn't make any sense at all. And if you continuously deploy stuff to production, why would you wait until showing it to your customer for the sprint review? So it's not natural at all. And this is kind of also what I meant with the idea of being post-agile. If you have everything in place in a really good way, you have a modern software development approach, you don't really need agile methodology to guide you in the way that you work together as a team. So absolutely.
And what keeps on busy buzzing in my head the whole evening? Jaap, Schuttevaar, coming in. I'm very curious about what do you think? Nice to see you on screen as well.
Yeah.
And how do you experience it? Because you work a lot with agile teams, right?
Yes, I do. It's constantly shifting, of course, because in the old days we had dev teams, and then we got DevOps teams. Now I've got a biz DevSecOps team, and so the complexity still is changing because how to fit all those expertise and knowledge in size that is manageable in one team. But to focus on your last remark about Kanban, I see a lot of teams switching over to Kanban for the wrong reasons, because they like to skip the ceremonies and the meetings they think are not really productive. So they like to have freedom, skip the meetings and do whatever. And that also is not the right way to do Kanban. I'm curious if anyone has experience with, well, it's new, it's called goal-setting Kanban. So it's Kanban, but the team may themselves decide the length of their sprints, and not once a year, but every time they start a sprint, they can think our next sprint will be 2 weeks or 3 weeks or 4 weeks. Of course, it has some implications with synchronization with other teams. Everybody has different cadences, but that might be something that you do keep in the mechanisms to learn and improve and to plan and to set expectations, but still to manage flow better in a Kanban style. So I'm curious if any one of you have already some experience in that.
Let's note some answers in the chat. Just a simple yes or no will do. And if I understood, Jaap, you said goal setting Kanban, right?
Yeah, goal set it. Yeah.
I see a lot of no's. Nope, no's coming in.
I might try to experiment with that, but I do have to say that in most circumstances, if you do it properly, you can minimize the overhead of the meetings with mature teams, stick to Scrum, blend in the XP techniques, and squeeze out DevOps from there. So there's no need, no excuse if you're doing Scrum that you can't do DevOps. With 16.
Yeah, but I was trying to make the point, not that we don't need a methodology or that methodologies are useless, or that you don't get any value from Scrum. I would definitely say I'm a fan of all the underlying principles of Scrum, and that you reflect on what you do and that you try to plan. It's always a good idea to plan, right? So these are all practices that you definitely should always apply in any project that you're going to do. But by coining the term post-agile, I was also trying to make the point that it's not about the methodology per se. There are maybe other things that can give you far more value as a team, practices that are maybe more important nowadays than really thinking about how to do Scrum in a proper way. Are we doing Kanban as it is meant? These are all tools that help you build better software. But it's not something that you should strive for. What you should strive for is get the best possible software in production in the best possible way, as quickly as possible, right? That should be the goal. And maybe focus more on setting up really good CI/CD practices and all the other things that we mentioned. But of course, I also think that post-agile, these kinds of ideas should maybe also be considered after you reach a certain maturity with your team. It's the same if you maybe start with Scrum. I think it's really important to follow all the ceremonies quite strictly so that you understand how they actually work. And maybe after you learned how all the different Scrum sessions work, you can try to determine, well, can we do a bit less? Can we maybe skip a retrospective after we did 20 retrospectives, and maybe we get less value from it, maybe change our methodology setup. And after a certain point, maybe you can also say, well, let's not talk about Scrum anymore. Let's more focus on CI/CD and find out how we can be the most effective in this biz, DevOps, security setup that we're currently in, right? So that's I think is important to keep in mind. You want to build software, and it's not about following a methodology per se.
I see parallels in the field of software architecture as well. So before well, pre-agile times in waterfall, you would do lots of functional design and then make a big architecture document like a PSA, a project start architecture, and then maybe some technical design, and then start building. And then we started doing agile, and then some people said, "Well, great! Now we don't need to do any architecture anymore." You still need to do this work, but you need to do work incrementally and do just enough work to get through your next sprint. So maybe you're doing small architecture design sessions of 1 hour once every sprint, but you still need to think about the bigger picture that you're going to build. It doesn't mean not doing it. It means doing it not upfront and in more smaller steps, and continuously adapting yourself to the ever-changing world around you.
I think we're on the same page.
Yeah. I think that as well, as I saw in the chat during this session, it depends, and are we allowed to say it's dependable on the context? And I think we're all, you guys from Open Value, but also we from KZA, we all like the pragmatic approach.
Yeah.
And I think the maturity of your team and the state of the maturity of your team is very important to see what you can improve, and what you also say, Roy, it's about training. It's about doing some following the method first strictly, so you improve your habits, and then you can move on to the next phase. Yeah, nice to hear. We would love to stay here for a while because we've got a very nice seat over here, comfortable with you guys on screen. If you would like coffee with it, take a beer maybe. We are quite comfortable over here, and we would like to have you still in this meeting, asking your questions. But also, if you have to leave, feel free to continue your evening. We will send the slides. Roy and Bert-Jan promised me that I could share them. I think there was a lot of information, a lot of interesting information. For me, it sometimes went quite fast. So I'm definitely going to look back to the recordings. I will share them as well with you. And as you guys are, I think, a little bit used to, you get a follow-up email from me with all those information included. I hope you all will answer the few questions I already dropped in the feedback form in the chat, and I will include it in the message as well. And also feel free to drop your suggestions or your questions for next knowledge sessions. I like to get some feedback or ideas to elaborate on next times. So don't feel shy, just share your thoughts. Thank you, Roy. Thank you, Bert-Jan. I'm moving to something I brought. 1 second. And we are very thankful for your hospitality.
Nice.
And here one from you.
Thank you.
This time I didn't import it myself, but I know it's a good one.
Okay, good.
I noticed this evening that you guys like to drink a beer as well, so I hope this one finds its way. And looking forward to continuing our cooperation. And thanks again for having us here.
Thank you.
Thank you. Thanks everyone for watching.
Thanks and have a nice evening, everyone. A digital round of applause.
Thank you. Bye.
Thanks, bye.
Thanks all. Everyone's leaving the